we talked about dividing polynomials using long division, and that allowed us to change a polynomial from standard form into factored form, which allowed us to be able to further graph that polynomial easier, because then we could see the zeros. Well, I'm going to show you a couple of crazy things that can happen when you're dividing polynomials that we didn't talk about in class. The first thing is crazy thing number one that I call, and it's called the case of the missing terms. So I'm going to give you an example. So let's say, for example, you were given the question, let's say we needed to divide x cubed minus 8, and we're going to divide that all by the factor of x minus 2. So let's set that up into long division form. So I've got x cubed minus 8 in here, and I've got x minus 2 going here. And remember, we talked about taking this first guy and he divides into this guy here. So we ask ourselves, how many times does x go into x cubed? And it goes in x squared times. Then we take the x squared and it multiplies by both of these guys over here. So x squared times x gives us x cubed, and x squared times negative 2 gives us negative 2x squared. Then I subtract these two, and I have x cubed minus x cubed, which is 0x cubes, and I have negative 8 plus 2x squared. And now we've run into a problem because these two are not like terms. And so I cannot subtract those or add those together. So I'm running into a big problem. Okay, and that's the missing terms. We're missing that x squared term. So there's a rule, and the rule is that when you're using long division, when you're dividing polynomials, that all powers, and we talked about this in class, but all powers must be written in descending order. Descending order. And not only that, but all powers must be represented. Must be represented. And that's both in the dividend, in this part here, and in the divisor, the things that dividing into it. All powers must be represented. Okay, so let's tackle this question again. So I'm going to go up and erase what we have here. There we go. And what we need to do is we need to include dummy terms. And they're just placeholders where there are missing terms. Right now I have an x cubed, I'm missing an x squared and x. So I am going to, again, let's get rid of this minus 8. And I'm going to include the dummy terms. So I don't have an x squared, so I'm going to indicate that by saying I have 0x squareds. It's just a placeholder. And I also have 0 x's. And then in comes, again, my negative 8 that was sitting in there. All right? So let's try this question again. X goes into x cubed, x squared times. And we're left with x cubed. X squared times x gives us x cubed. X times negative 2 gives us negative 2x squared. And now I have a guy for this guy to play with. Now they match. Remember, I'm subtracting. X cubes from x cubes gives me 0 of them. 0x squareds, subtract negative 2x squareds is going to give me a positive 2x squared. And then, of course, I pull down this next term, so plus 0x, and then I start all over again. X goes into 2x squared, 2x times. 2x times x gives me 2x squareds. 2x times negative 2 gives me negative 4x's. And then I continue on to do the math. So I'm running out of room here. So let's just erase these guys here. Hopefully you had that in your notes. Okay, let's keep going. All right, we subtract 2x squared minus 2x squared. There's no more of those x squareds left. I have 0 x's, subtract a negative 4x, so that's going to leave me with a positive 4x. I pull down this next guy, and I have a minus 8 down here, and I do the game again. X goes into 4x 4 times. 4 times x gives me 4x. And 4 times negative 2 gives me negative 8. And if I subtract 4x minus 8 from 4x minus 8, I'm left with 0, which makes me happy because that means that I won the game. And also, it's also telling me that, therefore I know that x minus 2 is a factor. Is a factor. Okay, good. So that's the first crazy thing that can happen is if you have missing terms, you have to fill them in with dummy terms. Let's take a look at the next thing that can happen. Okay, the next thing that can happen I've labeled as crazy thing number 2, ugh, leftovers. Like my kids say every Friday night, ugh, leftovers. So let's take a look at something that turns out really nice. I've got 15 and I divide it by 3 and I'm left with a nice value of 5. That's nice. But if I take 15 and I divide it by 7, it doesn't divide easily. And what it does is it gives me, well, it divides in 2 times, but then there's still a leftover because 7 times 2 is 14. I still have a remainder or a leftover of 1. All right? And so how that would look in long division, let's just remind ourselves, is 7 would go into 15 2 times. 2 times 7 is 14. I subtract those, I'm left with a 1, and 7 doesn't go into 1. But what I could say is the answer to this is 2, and this would actually be saying, okay, now take the 1 and divide it by 7. I'm just going to write that as 1/7. So 2 and 1/7. You could take the 1, divide it by 7, and get some decimals, but here's a nice exact answer, 2 and 1/7. And notice the 1 is the remainder, and the 7 was the divisor. It's what we were dividing by. Okay, so let's do the same thing with long division and see what happens. Okay, so here's a question with long division. Let's say I'm dividing the polynomial x cubed minus x squared plus x minus 5, and I'm dividing that by x squared plus x plus 1. Now here's something new that we haven't seen yet. The divisor is not a binomial, it's a trinomial, but it's okay, the same game. We play the same game. Double check that you have all of your powers written in descending order, and double check that all of your powers are represented in both the divisor and in the dividend. So now we play the game. X squared goes into x cubed how many times? It goes in x times. Then this guy multiplies all of these guys. X times x squared gives me x cubed. X times x gives me x squared. And x times 1 gives me an x. Then I subtract all these guys from each other. Those two get eliminated. A negative x squared minus another x squared gives me negative 2x squareds. And an x minus an x gives me 0x. But I'm going to write that down there because that's my placeholder. Then I pull down this minus 5 and I play the game all over. X squared goes into negative 2x squared, negative 2 times, giving me negative 2x squared, and then multiply this guy by all of these guys, minus 2x, minus 2. Again, we're going to subtract everything. Those two eliminate. 0 subtract negative 2x gives me a positive 2x. And negative 5 subtract negative 2 is negative 5 plus 2, which is negative 3. So now we try it again. X squared goes into 2x. Oh, it doesn't go into 2x because this degree is less than this degree up here. So therefore, we can't go any further. So this right here, this is my remainder. So what I can say then is, Okay, x cubed minus x squared plus x minus 5. This whole polynomial divided by this one, x squared plus x plus 1, is going to give me an answer of x minus 2, but that's not a nice clean answer. There's still this remainder. So plus whatever the remainder is. And we're going to take the remainder and pretend to divide it by the original divisor. And so it's going to be plus 2x minus 3 divided by x squared plus x plus 1. Just like what we did with the 2 and 1/7. Okay, there's the remainder, there's the divisor. And that's what you do with leftovers. Now, that means because I have a remainder, that's telling me that this factor right here is not, this polynomial right here is not a factor of this guy here. Because I have remainders left over, it's not a factor. All right, remainder, leftovers, sad.